Welcome again to the online video lecture series Essentials of MATLAB. This is chapter 8 Simulink, and these are the contents of this chapter: Introduction to the Simulink and Simulink software basics, how to create a Simulink model, then Simulink workflow, and importing and exporting data results. So let's start with introduction. Basically, Simulink software models simulate and analyze dynamic systems, or we can say when we do not have any kind of practical hardware and still we want to analyze that thing in virtual domain. For example, if you are having a circuit, like simply we can have a resistance, a power source, and a diode. So to analyze this circuit, basically, or we can say to analyze the input and output for this system, you must have these components. If you are not having this component and you want to simulate this system, then you can do this in virtual domain. And in the MATLAB, apart from only the electronic components, we are having lots of application and lot of dynamic system that we can create and analyze the things. So basically, Simulink supports linear and non-linear systems in MATLAB, modeled in continuous time, sample time, or a hybrid of the two. So system can also be multi-rate, having different parts that are sampled or updated at different rates. So there are lots of applications of the Simulink, like for example in aerospace and defense, automotive, communications, electronics and signal processing instrumentation. So the next thing is how simulation software interacts with MATLAB environment. Actually, when you start MATLAB, Simulink do not start with MATLAB because it's also very heavy. So it can slow down the startup of the MATLAB. Okay. So first time whenever you click on the Simulink to start it, it will take some time. So basically Simulink software is tightly integrated with the MATLAB environment and it requires MATLAB to run basically. It's a part of MATLAB. Depending upon it, define and evaluate model and block parameters. Simulink can also utilize many MATLAB features. For example, Simulink can use the MATLAB environment to define model inputs, store model outputs for analysis and visualization. And also we can define our own functions and that we can use in the Simulink. So basically, what is the difference between the programming until now we are doing and in the Simulink? You can say Simulink, we are having graphical boxes. In that we have to just drag and drop the boxes and we have to connect the boxes. You can just directly double click on any of the box. You can set up the properties as you want, or you can say you can directly write the programming as you want. The only difference in between Simulink and the normal programming, that Simulink do not need the programming what we were doing earlier. Simulink already provides an environment where we can analyze a lots of things, or we can say the predefined models or predefined blocks we can analyze using them. So in the Simulink software basics, we will learn how to start the Simulink software, then opening the Simulink library browser. We will see some of the details of the library browser and how to explore the blocks, then how to create a new model, and then how to simulate that thing. So basically, to open the Simulink, you have to write Simulink in the command window. That is the easiest way, or you can just directly click on the icon like this on the Simulink. I will show this when we will be doing some practical things on the Simulink. Let's just cover first theory part, then we will be creating the models on the Simulink. Okay, so this is the Simulink browser. So this is the tree structured library, and these are the particular blocks. Suppose if you click on the commonly used blocks, so these are the blocks inside this library, and whatever the block you have selected, the details is given in the block description. Okay, so to access the help of the Simulink, you can just write help, or you can see the demos or web resources. So it's already similar to the previous one. You can access the help. So let's create our new model, and to create a new model, the basic steps are: first you have to open a new window, then you have to add required blocks, connect the blocks, save the model, set the simulation properties as per your need, and run the Simulink model. So in this way we will start our simulation model and we will create a lots of models. Okay, so let's do it practically. So this is MATLAB's environment. To open the Simulink, just click on the Simulink library, or you can directly write Simulink in the command window. I'm gonna click on the Simulink library. So this is the Simulink library. Okay, I have opened it earlier, so it doesn't take time. But when you will click on this Simulink library, it will take some time to open this library. So this is our library browser, and this is a tree structured block. So on whatever the tree you will select, you will see a lots of blocks, and you can easily see a lots of function are here, like aerospace block set, communications, computer vision, DSP, and 3D animation, SDL verifier, lots of applications you can perform with the Simulink. So let's just go to the basics. Okay, so to create a new model, just click on here. This is the new model, or you can go to the file or new and model. Okay, so from either way you can start the new model. You can just click on the new model. This is our new model, and here we have to just drag and drop our elements, and I will explain the remaining GUI operators later, GUI parameters later. So let's create a model. First, we will create a very simple model. We need a source, and we are using sine wave. Just click, hold, and drag into this system. Now we are having sine wave. Okay. So whenever you double click on the sine wave, you can change the loads of property here. It's given. So in the same way, in every of the block, in every block you are having a lots of property, and this is a continuous wave right now. And if you want to make this as a discrete, just click on this thing and click on sample based. Okay, now we are having sample based, and the icon, and icon will change here. Okay, so there was error because we haven't defined the sample time, so just write 1. Now just apply. Now we are having discrete icon here. Okay, and you can also resize the icon as per, just drag and drop as per your need. So I'm not resizing it. Okay, so just we are having the sine wave. Now let's first analyze the sine wave. We should go to the sync so that we can display, we can have the display of the sine wave. Okay, so to connect these things, when you will move your cursor over this point, so this is the output point, so it will change into the plus sign, and you can click, hold, and move to the scope. Okay, and you can also connect, just click on the sine wave and hold control button and click on scope. Okay, so either way you can connect. So first I'm gonna change this again into the time base. Okay, now we are having a continuous wave, and just change this thing. Just double click on the scope. Now we are having our scope, and here we can set the timing parameters. We are providing the 20 time, and you can just click here to run this thing. Now this is our sine wave, okay, that we have plotted here, and let's just change it into the sample base, into the discrete. Okay, so when we are using the continuous input signal, then we will be using the continuous blocks. We are having lots of continuous blocks and lots of operations here. So I want to just provide a delay to this sinusoidal wave. So first, let's change it into the discrete, and I want 2 axes in the scope. So just go to the scope settings and number of axes. Here you can have any number of axes. Apply, and you can easily see we are having 2 axes and 2 input ports in the scope. Okay, now we want to just make it discrete, so just double click on this thing and click on sample based, and I am changing sample time also here. Okay, so now it's sample based signal, it's not continuous. Now I want to provide a delay. Okay, to provide a delay, because this is a discrete wave, just go to the discrete block, and in this we are having delay. Just drag here, we are having a delay, and now we have to connect this output to the scope. Okay, and this one to this line. Okay, so we are having sine wave and directly fed to the scope axis 1, and then we are having sine wave by a delay to the scope. Okay, just double click on the delay to change the delay. If you want to change, suppose if I'm having a delay of 5. Okay, and let's just run this thing. Just click on the play. Okay, and now you're having 2 waves. One is this sine wave, that is the original discrete sine wave on the sample base, and this is via a delay. So this is the delay we have provided in the scope. Okay. So in this way you can create your systems or create your models. You can save your model, okay, and it will save in the .mdl file. Just click on the save button and you can save mdl or slx. Okay. So let's you can save this thing, but I'm not gonna save. Okay. And one more thing, you can also print this model or using the HTML reports also. So just go to the file and click on the print, and here we are having lots of options that how we want to print this model, and we can also generate reports. Okay, so reports, we should go to system design descriptions. So when we click on the system design description, so whatever the value we have changed will be shown here. Okay, just click on the generate. So it will be generated using the name untitled, and it's beginning your report, and soon the report will get it. Okay. And this is all the logs of the report while we are generating the report. Okay, so it's converting the report. Just we will be having our report about the complete system. Okay, so this is our report. Okay, and in this report all the details are given. Okay, so it's a pretty nice report. So in this report, all the parameters you can easily see that whatever the parameters we have changed for the sine wave is already defined here. So whenever you create a model, you can just create your report so that anyone can create the system from this report. Okay, and lots of things are given here, and this is the content file of this report. Okay, and you can directly generate your reports from the model you have created here. And there's a one more thing, whenever you right click on any of the block, it will show you a lots of options, like you can convert it into the C++ code and SDL codes, PLC code, and lots of things are given here. Okay, so let's just move to another demos. Okay, okay, so this was one of the Simulink model that we have created right now. That was a very simple and very basic model, and let's just move to the communication system block diagram, and we'll see a demo from the communication system toolbox. Okay, so here I am having lots of demos that I have created. So I'm just gonna show you scopes of the communication systems. In this we are having input signal, and we have added some noise to that signal, and we want to analyze that what are the changes in that signal. So just directly right click, or you can say just directly double click on any of the model, and it will be open in the new window. So here we are having a wave, DSP sine wave, that is from the DSP toolbox. So these are all the parameters given here. Okay, and we are having a discrete eye diagram where we can analyze the interference, and this is the scatter plot where we are having the best opening time. The eye diagram, we are having a best opening time that is shown in the scatter plot. Then we have added the noise, that is a white Gaussian noise. We have added the Gaussian noise in this signal, and we want to analyze the eye diagram for this thing. Now will be having two eye diagram. One is for the pure signal that is not having any kind of noise, and another that we are having a noise in the signal. So this is the sample time I have selected here. Just click on the run. Okay, so it's compiling basically. So this is your eye diagram for the input signal, and this is your eye diagram for the noisy signal. Okay, and we will be having one more, the scatter plot. This is your scatter plot. Okay, so this is our original signal that we are passing through, and these are the scatter plot, or we can say the best opening time plot for the scatter, for the eye diagram as shown on the scatter plot. And these are the eye diagram when we corrupted the input signal. Okay, so in a similar manner you can analyze a lot of signal. You can analyze the frequency modulation and other things if you belong to that part. Okay, So there are a number of toolboxes and number of applications in the MATLAB Simulink where you can use a lot of things. And let's just see one more demo from the computer vision toolbox. Okay, computer vision system toolbox. And let me change the directory so we can have image, and we will come to know that how to import and export your data from the Simulink. In this part we will discuss this thing also. Okay, so in here in this directory I'm having lots of images, so let's just read one image. Okay, so let's just change the image. I want a grayscale image. Okay, so the gray, this image is already I'm having in this current directory, that's why it's reading this image. And let's show this image. I'm writing a function to show this image. So this is the image, and I want to change the image. Let's just change the image. Okay, yes, now we are having an image. So this is our image, and we will analyze this one using a Simulink. Okay, and we will import our data into the Simulink from the workspace, and we will also write our data into the MATLAB's environment back. Okay, so in the computer vision system toolbox, let's just create a new model. Okay, so let's first have our image that I want from the workspace. Okay, so double click on this block, and our variable was x. In that we were having the image. Okay, in the x we are having image, and just go to the analysis and enhancement, and I want to detect the edge of this block. Okay, so before detecting the edge, let's see what is our image. Let's have a sync video viewer. Okay, and let's analyze this image. What is the image we are having? So basically this is the image we are having. Okay, that we have seen earlier on the MATLAB's environment, and I want to detect the edge for these images. For this image, go to the enhancement and just click on the edge detection and insert the block here. Okay, now we are having the edge detection. So lots of filters are given for which robot can. Okay, so we are using Sobol operator, and let's just play this thing. Okay, so we are having Sobol operator, and let's just play this thing. So basically this is the image. In this we are having our images, our edges for that image. Okay, okay, so in this way we can analyze a lots of system, and we can use a lots of blocks from different applications. So basically when you are working with the Simulink, then you must concentrate on the first, on particular application or particular field. We can say if you are working on the communication systems, then you should use Simulink for particular that thing only. Okay, and basically we can say first start with an application, or first start with the field in the Simulink, so that you will have proper knowledge of the Simulink, that how to interact and how to save the systems. Okay, so thank you very much. This was all about the Simulink, and here completes the chapter.